All right. So today what we're going to do, we're going to start our lesson 6.2, which is proportional versus non-proportional relationships. And you can see I've got an example here of a graph and an equation that are proportional and a graph and an equation that are not proportional. And we're other than being able to identify these relationships, we're not going to go too far into it. We just need to know the difference between the two. So, our learning intention today, we're going to be learning about percents and proportions. Our success criteria is that we can recognize and represent proportions in various forms. And we're going to work specifically with tables, graphs, equations, and we're going to work a little bit with word problems just so that you can see what it looks like, what the difference is. So, when I'm identifying a relationship is proportional if the ratio of our output, y, divided by the input, x, is constant. And this goes with our equation that we learned the other day, our y equals k times x, because remember, we've got a constant with that proportion. That k is my constant, okay? So it will have a constant. And that just means that when I divide my output by my input, that I'm going to have a constant there. So in an equation, we have two different representations. We've got proportional and non-proportional. In an equation, we need to know that the difference between our constant of proportionality and a slope, okay? Because a proportional relationship has a constant of proportionality. It just means that we have a number that we are going to multiply by our input every single time. We're not going to change it in any other way. So here with our proportional relationship, our constant of proportionality is k, or in this case, our constant is 4 for this equation. Now, non-proportional looks really similar. The only difference is we add or subtract at the end. So if you see a plus or minus, that means that we're changing that constant. It's not constant anymore because we've got something that's changing it called a y-intercept. So that number that we add at the back is called a y-intercept. So a non-proportional relationship has a slope and a y-intercept. So what I want you to do is looking at that, which one of these equations is not proportional? Okay, do not be fooled because even though I have zero added at the end here, this is not a proportional relationship because or this is the only not proportional relationship. This one is proportional because really if I'm adding or subtracting zero, I'm not adding or subtracting anything. So it doesn't change this proportional equation here. So these three are all the same equation. They are all proportional relationships. But B is not proportional because I'm adding 5 at the end. So that changes it where it's not a constant rate anymore. The next example we're going to use is graphs. And graphs are pretty easy to see because what we're looking for is if we have a proportional graph, our line is going to pass through the origin. The origin is at 0, 0. It is right here. So I always think of it as like the corner. I always think of it as passing through the corner. So the line, it's going to be a straight line that passes through the corner or the origin or 0, 0. Okay. Non-proportional, it's going to be a straight line, but it is not going to go through the origin. It is going to pass through somewhere else. It can pass either above or below. It doesn't matter, but it will not be directly on the origin. If it's on the origin, it's proportional. If it's not proportional. So tell me if this is proportional. This is not a proportional relationship because if we look at it, first of all, we don't have a constant rate of change. These dots are all over. It does not form a line. The next thing that we need to notice is that we can't even tell if it passes through the origin. There's no dot on the origin. So those two things make it not a proportion. It has to form a line and it has to go through the origin. Those are the two must do's in order for it to be a proportional relationship. Let's look at this one. Is this one proportional? This one is kind of tricky looking because even though it's not attached, it does form a straight line. I can make a prediction from it. So this is a proportional relationship. Our rate is constant because you can see that every time I'm going up 1, 2, 3, 4. and I'm going over 1, 2. I go up 1, 2, 3, 4, and I'm going over 2. So my rate is constant for that, and it is passing through the origin. So this makes it proportional. What about this one? Is this one proportional? Yeah, this is also a proportional relationship. Our rate is constant. We can tell that if whenever we're saying a rate is constant, it just means that it's able to form a straight line. Our data passes through the origin, so it passes through right here. So we can see that it is a proportional relationship. Next is tables. And tables, there's two ways to look at it. First of all, we're going to have a constant rate of change, and we're going to also, sometimes we can also see on this one, it passes through 0, 0. When I'm saying it has a constant rate of change, I'm just saying that if I divide my y value by my x value, it's going to be the same every time. So here we're saying 0 divided by 0. That one really doesn't matter. You can't really check if you have 0, 0, but you go through and you actually start where it's a number, a non-zero number. So if I do 6 divided by 2, I get 3. If I do 12 divided by 4, I get 3. If I do 18 divided by 6, I get 3. So that's what I mean by a constant rate of change. Now, non-proportional relationship won't have a constant rate of change. Our rates are going to vary. So we can even start here with 4 divided by 0. I can't do that. So we're not going to start with 0, but I can do 10 divided by 2. If I do 10 divided by 2, I'm going to get 5. If I do 16 divided by 4, I'm going to get 4. So already we can see that since those are not the same number, it is not a constant rate of change. So that's what makes it not proportional. Go ahead and check this one. Remember, we're just going to pick one value. So you can pick any one, at least pick a few of the values, but you're going to divide and see if you get a constant rate of change. On this one, you do get a constant rate of change. What I did is I went through each one of the numbers and I divided it by, divided my y value by my x value. So if I do 5.5 divided by 2, I get 2.75. And that works if I am working with any of these numbers. If I do 11 by 4, I'm going to get 2.75. You can put in your calculator 16.5 divided by 6. You're going to get 2.75. And you want to make sure too with these tables, because sometimes you will have a different number thrown in just to make sure that you've tested all of them. So make sure that you check all of those. If you hit one that is not the same, then it's not proportionate. You can say that automatically. But if all of them are the same, you are going to have a proportional relationship. Okay, go ahead and check this one and see if it's proportionate or proportional. This is not a constant for the data. There is no constant rate, so no, this is not proportional. For example, if I go through and I do negative 13 divided by 2, I am not going to get the same answer as if I do negative 1 divided by 1, because negative 13 divided by 2 is going to be 6.5. Negative 1 divided by 1 is not 6.5, so we won't have the same rate for all of those numbers. The last example we're going to do is word problems. And with word problems, you can tell that it's proportional because you're going to have a basic thing that's going to say you save something each month. You do one thing each time. And it's going to be pretty straightforward. In a non-proportional relationship, it gives you a different start amount. So here in our non-proportional relationship, we're saying we start with 50 and then we save $25 each month. So automatically, because I don't start at 0, it's going to be non-proportional. If it doesn't tell me I start somewhere, we're going to just assume that I start at 0. So that's the difference between this proportional relationship and this non-proportional. Even though each one is saving $25 each month, here I'm starting with no money. So it's saying, okay, well, I'm just going to add 25 each month. My other one, maybe I had a birthday. I started with $50. So I have a starting amount and then I save $25 each month. That is the conclusion of this note guide. Make sure that as you finish the Ed puzzle and fill out your notes, you are going to go ahead and do the quizzes check, and then you will go in and do your formative, your independent practice.